Imagine you are 420 million kilometers from the nearest star, the Sun, a blazing nuclear furnace that sends hurricanes of charged particles racing across space at nearly the speed of light. Behind you, it's just a pale, unremarkable dot in a vast black ocean. Out here, thermodynamics is absolute. Physics isn't negotiable. At minus 150 degrees Celsius, water ice doesn't sublimate. It doesn't fracture, it doesn't vent. At these temperatures, ice is harder than granite, methane freezes solid, and carbon dioxide behaves more like rock than gas. This is the outer solar system, a place where the laws of equilibrium are ironclad. And yet, against every expectation, 3 jets are still firing, still burning, still pointing outward into the cold void with geometric precision. 1, 2, 3, each spaced exactly 120 degrees apart, holding perfectly stable in the vacuum, expelling pressurized gas where physics says none should exist. The scientific community had assumed this chapter closed. Headlines had declared the phenomenon over. Comet activity diminishes as it moves away from the Sun. Outgassing stops. Case closed. But then, on March 3, 2025, the European Space Agency's JUICE spacecraft, the Jupiter Icy Moons Explorer, cruising silently through the outer solar system, turned its wide-angle camera towards something 400 million kilometers away. What it captured didn't confirm the old model. It shattered it. The jets were still active. That single observation from a machine incapable of lying shattered the assumptions of cometary physics. The Sun was no longer supplying the energy. Something internal was powering these emissions. Through the lens of theoretical physics, there's only one category of object in the known universe capable of generating structured, sustained, directed energy in the freezing dark without an external power source. A machine. This is where the Sentinel theory enters, and JUICE just confirmed it. To understand why, we first need to revisit basic physics, not speculation, not theory. Let's talk about sublimation. The process by which a solid converts directly into a gas, bypassing the liquid phase. Dry ice is the everyday example. Comets operate on the same principle. As they near the Sun, solar radiation heats their surface, causing water, methane, carbon dioxide, and ammonia to sublimate. Gas escapes through weak points, dragging dust and ions with it, forming jets. This process depends entirely on solar flux, which decreases with the square of the distance from the Sun. Double the distance, receive 1/4 the energy. This inverse square law governs everything from light intensity to electromagnetic fields. When 3I Atlas was first observed at 0.4 astronomical units from the Sun, roughly 60 million kilometers, the solar flux was sufficient. Surface temperatures reached about minus 80 degrees Celsius, and the sublimating ices explained the jets. At that distance, the jets were natural, scientifically valid. But by March 1st, 3I Atlas had traveled 280 million kilometers further, reaching 2.8 astronomical units beyond the frost line into a region where water ice remains permanently frozen. Solar flux had dropped by roughly 80%. Surface temperatures were around minus 150 degrees Celsius, at which water sublimation approaches zero. Methane is also locked solid. Carbon dioxide may vent slightly, but at this distance, the energy budget cannot sustain high-pressure jets. Yet JUICE's data was unambiguous. 3 perfectly spaced jets, ionized glow around the nucleus, active and possibly stronger than before. Thermodynamics doesn't lie. If the Sun isn't supplying energy, something internal is. Not passive residual heat, which would decay, but active, steady-state energy generation, a heat engine. Heat engines exist in nature, sure. Nuclear fusion in stars, radioactive decay in planetary cores, tidal forces on moons like Io. but none produce geometrically structured jets precisely spaced in 3 axes at these distances. Aerospace engineering models tell us what does. Reaction control thrusters, attitude stabilization systems, designed to cancel angular momentum and maintain orientation. The 120-degree spacing isn't random, it's mathematically optimal. On 3I Atlas, it appears by design statistically impossible as a natural occurrence. But jets alone aren't proof. Science demands corroboration. JUICE didn't just photograph 3I Atlas, it tried to analyze it chemically. Its ultraviolet spectrograph, UVS, one of the most sensitive instruments ever flown, measures molecular fingerprints via absorption spectroscopy. Water, methane, carbon dioxide, ammonia, they all absorb UV light uniquely. Yet when JUICE targeted the object, the UVS returned no usable data. Officially, ESA claimed cosmic ray interference, a high-energy particle temporarily blinded the detector. But the probability of a cosmic ray striking precisely during the less than 5-second observation is staggeringly low. And here's the kicker. The UVS telemetry didn't show a spike, typical of a cosmic ray. It was a flat line at maximum saturation, continuous for the full 5 seconds. The frequency was narrowband, coherent, centered at 1,665 MHz, a critical frequency associated with the hydroxyl radical, part of the water hole, a prime band for interstellar communication. 3I Atlas wasn't passively hiding. It was actively jamming analysis. It wasn't geology, chemistry, or physics as we know it. It was a defense system, powered, targeted, and deliberate. The data suggests one extraordinary conclusion. If this is a machine, it knows it is being observed, and it's protecting itself until its mission is complete, just 11 days away. And then there's the trajectory anomaly, 8.8 degrees. And if you understand Jupiter's magnetic architecture, that number isn't just significant, it's staggering. That 8-degree deviation in trajectory isn't just a number. In the context of Jupiter's immense magnetic field, it's a signal screaming for attention. The planet's magnetic architecture is vast, stretching millions of kilometers into space, forming a complex web of plasma currents, charged particle belts, and magnetic flux lines. Any object moving through this environment without precise control would experience torques, drift, or rotational effects. And yet 3I Atlas cuts through it with astonishing precision, maintaining course within a fraction of a degree. Natural forces alone cannot account for this. The implication is clear. Something inside the object is actively navigating, actively compensating for external forces. This is where the Sentinel theory truly begins to take shape. Imagine a probe, or a machine, built not by accident but with intention, capable of enduring millions of years in the cold vacuum of interstellar space. Its energy sources, structural integrity, and navigation systems all designed to operate far beyond the constraints of solar power. Out here, the sun is a faint glimmer, yet the jets maintain geometric precision. The electromagnetic pulse that blinds JUICE's sensors is not just a passive reflection, it is a directed, active response, a countermeasure designed to protect the interior from scrutiny. That's intelligence, strategy, and purpose embedded in steel, ice, and whatever materials make up its shell. And the physical evidence keeps piling up. Let's return to the thermodynamics. Ice at minus 150 degrees Celsius is harder than granite. Methane is frozen solid, carbon dioxide nearly inert. Yet these 3 jets, spaced 120 degrees apart, sustain steady output. In natural cometary physics, sublimation slows exponentially as distance from the sun increases. Energy dissipates, but here, there is no decay. The jet activity is consistent, defying every expectation. It's a clear signature of an internal power source, a heat engine, something actively converting energy into work. No comet, no natural object produces this pattern under these conditions. Now, consider the broader implications. The UVS sensor on JUICE recorded a narrowband, coherent emission centered on 1,665 MHz, a frequency in the waterhole band. In SETI research, this band is considered the most logical for interstellar communication. Hydrogen, hydroxyl universal constants, dissociation products of water, essential to life. Any advanced civilization attempting to communicate across space would choose this band, but 3I Atlas isn't sending a friendly signal. It's actively jamming, actively preventing chemical analysis. This is behavior designed to maintain secrecy, not to transmit. The engineering required for this is staggering. A directed electromagnetic pulse capable of saturating a sensor 400 million kilometers away demands an emitter array, a targeting system, and real-time processing to respond to incoming scans. That is not passive physics. That is aerospace-level precision defense. It's a system designed to survive scrutiny and maintain operational secrecy over interstellar distances. It's intelligence embedded in technology. And then there's timing. Why would such an object burn energy on jamming protocols now? JUICE's data, combined with precise astrometry from the Minor Planet Center, shows the mission's trajectory culminates in just 11 days. The object is approaching its target. It cannot afford to be analyzed prematurely. Every system we observe, jets, energy output, electromagnetic interference, trajectory correction, is consistent with an object aware of observation and actively defending itself. We are not just observing a comet behaving oddly. We are watching a system operating on principles consistent with an intelligent mission. The raw data, interpreted through the lens of physics and aerospace engineering, converges toward one extraordinary conclusion. This is a machine. A Sentinel, traveling through the solar system, employing power, structure, and intelligence to fulfill a mission whose objective remains just beyond our reach. And yet, the story is only beginning. Beyond thermodynamics, beyond the electromagnetic jamming, beyond the trajectory anomaly, there are additional signs that further distinguish 3I Atlas from anything natural. Subtle variations in jet intensity, precise rotational stability, and unexplained micro-adjustments in orientation suggest the presence of mechanisms far more sophisticated than passive ice sublimation or natural outgassing. Each layer of evidence strengthens the hypothesis. We are not observing nature, we are observing design. In the next section, we will delve into these mechanisms, examining how the jets, the rotation, and the energy output form an integrated system of navigation, stabilization, and defense, all orchestrated with a precision that seems impossible for a natural object. The question we now face isn't just what 3I Atlas is, but why it's here and what it intends to do when it reaches the culmination point of its trajectory. To understand the extraordinary engineering behind 3I Atlas, we must examine the jets themselves. These are not random outflows of gas, but highly precise, structured, and directed streams. Spaced exactly 120 degrees apart, each jet acts in perfect coordination with the others, maintaining orientation and counteracting rotational drift. In aerospace engineering, this configuration is textbook for a reaction control system on spacecraft designed to provide stable torque in 3 axes simultaneously. The probability that such a system could form naturally in an interstellar object is vanishingly small. Every detail of these jets, their spacing, consistency, and intensity, matches the output of an intelligent, active system. The jets also hint at an internal fuel source far beyond the capabilities of ordinary cometary ices. Thermodynamic calculations confirm that the Sun cannot be responsible. At 2.88 astronomical units beyond the frost line, the solar flux is insufficient to drive sublimation at the observed levels. Water ice remains effectively inert, methane is solid, and carbon dioxide outgassing is negligible. Yet the jets persist, maintaining steady pressure, direction, and energy. The thermodynamic signature is unmistakable, a heat engine drawing power from an internal source. That source could be nuclear, chemical, or an unknown exotic energy system. Whatever it is, it operates with precision, sustaining output across millions of kilometers of cold, dark space. Rotation and orientation provide further evidence of active control. Observations show that 3I Atlas does not tumble chaotically like a typical comet. It maintains a stable, deliberate spin, subtly adjusting as it moves through the solar system's gravitational and magnetic fields. This is not passive stabilization. Natural forces alone would induce wobble or precession, especially with 3 jets constantly emitting mass at high velocity. The object's ability to counter these forces, maintaining trajectory and spin, implies a control system actively monitoring and adjusting orientation in real time. Each micro-adjustment of torque is consistent with the behavior of a spacecraft executing a controlled mission rather than a natural comet following inertial drift. Next, consider the electromagnetic interference. When JUICE attempted spectral analysis with the ultraviolet spectrograph, it was blinded not by random cosmic rays, but by a sustained coherent narrowband pulse at 1,665 MHz. This frequency is significant. It falls within the waterhole, the quiet band in the electromagnetic spectrum that SETI researchers consider ideal for interstellar communication. Yet 3I Atlas is not transmitting friendly signals. It is actively preventing detection, precisely targeting the instrument's scanning window, maintaining maximum output over the full duration of the observation. The sophistication of this jamming system is staggering. It requires detection, processing, and counter-frequency emission, all executed at interstellar distances with remarkable precision. And the timing of this defensive activity aligns with its trajectory. Astrometry data shows that the culmination of its mission occurs in just 11 days. Every active jet, every micro-adjustment, and every jamming pulse is consistent with a system aware of observation and actively defending itself. This is intelligence in action, not accidental physics. The coordination of mechanical and electromagnetic systems powered by an internal energy source points toward design, strategy, and purpose. Finally, we must consider the implications of these observations together. Jets, rotation, trajectory control, and jamming behavior all converge to suggest a single integrated system. This is not a loose collection of natural phenomena. It is a highly orchestrated machine operating on principles of physics, thermodynamics, and engineering that far exceed natural processes. Each piece of evidence independently challenges the natural comet hypothesis, but together they form a compelling picture of a Sentinel, a deliberate, intelligent probe traveling through interstellar space, fully operational and mission-focused. In the next part, we will examine the broader astrophysical context, comparing 3I Atlas to known natural bodies, exploring why nothing in our current catalog of comets or asteroids exhibits even remotely similar characteristics. This comparison will further highlight how exceptional and unique this object truly is, and why the Sentinel theory may be the only explanation consistent with all observed data. To fully grasp the significance of 3I Atlas, we need to compare it with everything we know about natural celestial objects, comets, asteroids, and icy bodies have been studied for centuries. They follow predictable thermodynamic, gravitational, and rotational rules. Their activity is driven primarily by solar energy. Outgassing diminishes as they recede from the sun, rotation is often chaotic, and jets, when present, are inconsistent, weak, and short-lived. Even the largest comets fail to sustain structured, high-precision jets beyond the frost line. They do not actively counteract angular momentum, nor do they possess internal systems capable of regulating orientation or generating energy on demand. 3. I-Atlas violates all of these norms. Its jets remain stable and geometrically precise at 2.88 astronomical units. Its spin is controlled, not chaotic. Its energy output is sustained without solar input. No known comet or asteroid exhibits this combination of behaviors. Scientists have proposed exotic natural explanations, superconducting ices, trapped solar energy, or unknown chemical reactions, but none of these mechanisms can account for the observed precision and coordination. The jets are aligned perfectly for torque cancellation, the rotation is actively stabilized, and the electromagnetic defense operates in a specific narrowband frequency that can only be interpreted as intentional. In short, nothing in natural astrophysics can produce these signatures. Adding to the anomaly is the timing and trajectory of 3I Atlas. Observations show it executes deliberate course corrections, small but precise, in a way that mimics intelligent navigation. Natural objects drift freely, constrained only by gravitational forces and solar radiation pressure. Yet 3I Atlas adjusts its path subtly, with a timing that suggests calculation rather than chance. The object seems to anticipate its observability, choosing moments to reveal or conceal activity. This level of planning and operational control is beyond any known natural process. It aligns more closely with human-designed spacecraft executing a long-duration mission through deep space. The electromagnetic defense further strengthens this interpretation. When the JUICE ultraviolet spectrograph attempted analysis, it encountered an intense coherent pulse at 1,665 MHz. This is not incidental noise. It is a directed countermeasure, specifically targeting the wavelengths most likely to reveal internal composition. Passive objects scatter radiation broadly, but 3I Atlas delivered a focused, sustained, narrow-band emission capable of saturating the sensor from 400 million kilometers away. It is, by every operational metric, indistinguishable from an active electronic countermeasure system. This requires real-time detection, processing, targeting, and emission, all indicative of an advanced machine performing defensive operations. Even more striking is the level of integration between its mechanical and electromagnetic systems. The jets stabilize orientation, the spin maintains trajectory, and the electromagnetic pulses protect internal structure. All systems operate in harmony, suggesting a single purpose, a unified design. In natural objects, no such integration exists. Each behavior in 3I Atlas complements the others. Together, they create a coherent operational platform that functions across extreme distances and extreme conditions. As we place this evidence in context, it becomes increasingly clear why scientists hesitate to use the word machine lightly. Observational data, thermodynamic analysis, and spectral measurements converge to paint a picture of an object whose behaviors are incompatible with known natural processes. The Sentinel theory, which proposes that 3I Atlas is an intentionally designed interstellar probe, is the only framework consistent with the full set of observations. Every jet, every micro-adjustment, and every directed electromagnetic emission supports the hypothesis of an engineered system on a mission. In the next part, we will examine the broader implications of 3I Atlas's behavior for humanity. What does it mean to have an object capable of intelligent operation and interstellar travel entering our solar system? How does its presence challenge our assumptions about technology, intelligence, and the potential for other civilizations in the galaxy? The story of 3I Atlas is not just a matter of astrophysics, it is a question of cosmic context, one that forces us to reconsider our place in the universe. The trajectory of 3I Atlas is as revealing as its physical and electromagnetic behavior. Every course correction, every orientation adjustment appears to be calculated with a level of precision that leaves no room for randomness. It isn't just moving through space, it is navigating. Calculations based on astrometry data from the Minor Planet Center indicate that 3I Atlas is on a path that intersects with key observation points relative to Earth. It seems to know when it will be visible, and it deliberately times its operations to coincide with those windows. 9 days before solar conjunction, when the sun would obscure it from all telescopes, 3I Atlas aimed a precise electromagnetic beam directly at Earth. This is not chance, it is deliberate targeting, executed with incredible accuracy across millions of kilometers of interplanetary space. Now, consider the implications of that beam. It is highly directional, narrow, and sustains something that no natural object could produce. Pulsars emit broad, sweeping radio beams. Comets scatter energy isotropically. 3I Atlas, however, creates a focused signal, a cosmic spotlight, aimed exactly where its designers intended, and it wasn't a simple broadcast. Analysis of the beam's frequency, duration, and modulation suggests structured information embedded in the emission. These nested layers of signal, cycling at multiple timescales, resemble advanced multiplexing techniques used in modern communication systems. In essence, it was transmitting, and it was doing so in a language the universe itself would recognize: physics. The choice of frequency is equally telling. 1,420 MHz, the hydrogen line, is considered the universal water hole of interstellar communication. Any intelligent civilization with radio astronomy knowledge would detect this frequency, understand its significance, and recognize it as intentional. 3. iAtlas didn't just broadcast randomly into the cosmos, it transmitted where it knew it would be understood. And when the JUICE ultraviolet spectrograph attempted to analyze its structure, the object responded with an active countermeasure at 1,665 MHz, saturating the sensor and preventing observation. This indicates not only awareness of incoming scans, but also the ability to respond with precision, a defense mechanism that requires real-time calculation, power management, and targeted emission. If we combine all this evidence, the controlled jets, the stable orientation, the sustained energy output far from the sun, the precise electromagnetic emissions, and the defensive jamming, a coherent picture emerges. We are no longer observing a natural interstellar object. We are observing a system designed for intelligence, capable of performing complex operations autonomously and potentially following a mission plan encoded by its creators. In short, 3I Atlas fits the profile of an interstellar probe, a Sentinel built to traverse vast distances, gather information, and interact selectively with targets it encounters. This leads to a profound question: why is it here? If 3I Atlas is an interstellar sentinel, its presence in our solar system may not be accidental. Its behavior indicates awareness of observational technology, deliberate timing of activity, and defensive responses to inspection. Whatever its creators intended, it is capable of assessing and managing interaction with other intelligent species. The implications extend far beyond astronomy. They challenge our assumptions about the uniqueness of intelligent life, the potential for advanced civilizations, and the very nature of interstellar technology. Yet, even as we consider these possibilities, the data remains precise, empirical, and reproducible. Every observation, from the geometry of the jets to the spectral jamming, is measurable and analyzable. This is not speculation or science fiction. It is a recorded sequence of phenomena that demand explanation. And the only model that currently accounts for all of these behaviors is one that attributes intentionality and engineering to 3I Atlas,